Hello everyone, and welcome to ActorNet Bootcamp 2.0. This is going to be the first of our step-by-step videos that kind of walk you through each of the lessons, and today we're going to be starting with Unit-0. Now, if you don't know who I am, my name is Aaron Standard. I'm one of the creators of ActorNet. I wrote the original Bootcamp 10 years ago, and I wrote the brand new one that we're going to be going through today as well. So to get started, the first place we want to go and look is we want to take a look at either the Akka Bootcamp repository in the GitHub organization for Petabridge. If you go down here and click on this link, this will kind of take us to the Bootcamp landing page, or you can just jump right here. Both of these links are in the description. We're going to scroll down to Start Bootcamp. Now, if you want to get the lessons emailed to you, you can go ahead and fill out your email information here. If you just want to skip and go straight ahead to the lesson content, which is what we're going to do today, just click this button below, and this will take us directly to each of the lessons. So what we're going to start with is Unit-0, which is basically our hello world for learning Akka.net. Now, we have a whole section right here on why learn Akka.net. We have a totally separate 2-minute long video that kind of explains the use cases for Akka.net and why it's useful, why it's helpful. We're going to go ahead and assume you've already watched that, and we're going to dive into the first lesson where we're actually going to do some real programming with Akka.net. So we're going to go to Unit-0, our first Akka.net application, and that's where we're going to begin. Now, I guess one thing I should point out before we get too deep into the weeds here, you should go ahead and clone Akka.net Bootcamp onto your local machine. Now, you actually don't really need it to complete any of the lessons in Unit-0 or Unit-1, but at some point in the future, we might have like a base template you're going to work from there. So you want to go ahead and get that loaded. We also have all of the completed solutions for each of the units available in the Unit-0 and Unit-1 folders, respectively. Now, the first thing we're going to go ahead and try to do is we're going to go over what type of application we're going to build today. Our basic Akka.net application we're going to use is we're going to create a brand new word counter application where we're going to go ahead and attempt to count the number of words that appear inside a document. This is a really good basic way to try to get a handle on how to work with Akka.net. And if you've never worked with a .NET command line before, this might be new for you as well. I'm running on .NET 8 or 9. I can actually use either in this case. But if you have new versions of .NET in the future, this will all still keep working. But we're going to go ahead and use this .NET new console command to create a brand new console application. So I'm going to go and copy this real quickly from the Bootcamp lesson structure here. So I've gone ahead and I've copied this instruction, and I'm going to go ahead and make a new folder. Let me go ahead and open up a PowerShell tab. Actually, that's kind of my preferred shell to work with. Let me go ahead and close this one out. All right, and I'm going to go ahead and make a new directory called Bootcamp. Okie dokie, and I should now have, if I go into this directory, Akka word counter, I should go ahead and have a little C# project and a program.cs here. And if I print out my program.cs, you'll just see that it only has like a little console.write line in it. So this is basically a hello world application. And this .NET New template that I used is one of the built-in ones that's available whenever you get a brand new .NET install. We're going to eventually install this Akka.templates package, which has some Akka.net specific .NET New templates, but we're going to build Unit-0 just using vanilla C# for now. Now, the next thing we need to go ahead and do is add the Akka package to our solution as well. So we're going to go ahead and type out .NET. Okay, we're going to go ahead and add .NET add package Akka, which you can see the instructions there. And that is going to go ahead and add this package to our solution. And if I take a look at our Akka word counter, you'll see that this package reference include Akka, and the current most recent version is 1.5.3.8. You'll see that that's been added to our project here. And if I run a quick .NET build, everything will work the way we expect. Now, we're not going to do everything from the command line. I'm going to fire up JetBrains Writer in just a second here, which is my preferred editor, but you can also use VS Code or Visual Studio. Doesn't matter. We're not using any features that are specific to any one of those IDEs. Okay, so the next thing we need to do is we're going to go ahead and actually open this project in our IDE, and then we're going to start actually coding some Akka.net. So let's do that next. Okay, so I've got my little Akka word counter application open, and I've got my program here. We're going to go ahead and get rid of this sort of old code here. This is one of these sort of minimal program.cs files here. We're going to get rid of that. And instead, I'm going to begin trying to work with Akka.net. So the first thing we need to do to work with Akka.net is create an ActorSystem. So we'll do ActorSystem, my ActorSystem equals ActorSystem dot create. Yeah, sure, why not? Go ahead and do that. And then I'll go ahead and say, my ActorSystem dot log info. Yeah, that sounds good. We're using a little bit of Copilot here. And then I'll go ahead and await for my ActorSystem to terminate. That looks good. Let's run that real quickly. By the way, one thing I'm going to try not to do as part of these tutorials is just copy and paste stuff from the documentation. I don't think you should either. You'll actually learn quite a bit more if you type it out. You'll go ahead and build some kinesthetic memory there. The first thing that we've done here is we've started an ActorSystem and then used the ActorSystem's built-in logger to go ahead and write out just a little hello world to the console. And you can see that appear right here. So the first question you're going to ask is, what is an ActorSystem and why do we need to create one? All Akka.NET actors have to exist as part of, let's say, an address space where they can message each other. And by default, when we're working inside a single process, that address space all exists in memory. But each actor gets its own kind of unique URI that represents it inside the actor hierarchy. And the actor system is what's responsible for maintaining that. It basically maintains the addressing system. It also provides some other common bits of infrastructure all the actors need in order to run. Good example of that would be the dispatching system, which is how actors get scheduled to process their messages. By default, the dispatcher that we use is just the .NET thread pool, nothing special or fancy, but we can actually customize dispatchers. We can also customize mailboxes, which are the queues actors use for storing messages. The actor system is basically the piece of infrastructure that configures all of that and makes all those resources available for actors to start. So in order for us to actually create and start actors, we need to have an actor system first. Typically, there's only going to be one actor system per process usually. So if you're running, let's say, a big distributed system with actors that's built using Docker containers or Kubernetes or whatever, typically there'll be one actor system per container or per pod or what have you. So that's the actor system. Now that we have an actor system, we should probably create some actors. That's the whole reason we're here, right? Well, I'm going to go ahead and create a really simple hello world sort of level actor here. So let me go ahead and create a new class. We'll call this hello actor. And now in Akka.NET, there's a couple of different actor base types you can use. For the local sort of development scenario that we're working with, we only really need to care about two. The untyped actor, which is sort of the most bare bones actor base type. It has some performance advantages over the other base type, which is called the receive actor. But the receive actor has syntax that's a little bit easier to kind of read and understand. It also is a little bit easier to use for doing async and await, which is something that we'll learn a little bit more about later in Bootcamp. For the time being, let's go ahead and do an untyped actor. Now, the untyped actor needs to have an abstract method filled in called onReceive. The way actors work is we send actors messages and actors are going to pattern match on that message using like a switch statement in C# to determine what type of message this is. And then we'll run a message specific handler to basically produce output or maybe write something to the log or send a response message back. Sky's the limit, whatever you want to do. What we're going to do here is we're going to make this really simple. And I'm going to create a logging adapter. This logging adapter is Akka.NET's built-in construct for doing logging. It's possible to plug other loggers into it. So you can actually plug Microsoft.extensions.logging or Serialog or nlog or log4net or whatever, all behind the scenes. And we'll talk about that a little bit more, I think, once we start getting into Akka hosting, which will be in Unit 1 sometime. But for all intents and purposes, this is kind of our universal abstraction for accessing Akka.NET's built-in high-performance logging system. So we're going to create that here. And next, we're going to write a little switch statement on the message. And if the message is a string, we'll go ahead and we put a little breakpoint there. We'll go ahead and do log info. And, I'll go ahead and just say, received message 0. This will go ahead and do string formatting under the covers for us. So that looks well and good. And then we're going to go ahead and access this property, the sender. And we're going to send a reply back. So I'll go ahead and I'll take the original message and tack on a little reply there. So this is a really common messaging pattern called reply to sender. Whenever you receive a message from another actor, this sender property will be populated. Now, if we received a message from something that's not an actor, such as, let's say, the foreground process of our console application here, this sender value will basically point to what's called the dead letters collection. And we'll go ahead and see a dead letter get logged. You're going to understand what that means in just a second. Next thing I'm going to do down here, this is just a little bit of a boilerplate. That's generally a good idea. Our default handler, which is that if any of our specific message handlers where we're looking for certain types of messages, if none of those are hit and we get some message that we're not programmed to receive, the best practice is to dump that into this unhandled message handler right here. This will log a warning, and we'll also go and publish to a topic lots of little like diagnostic tools can subscribe to. Typically, if you hit this block of code, it means you've got a programming error. Either this actor is receiving messages it's not supposed to, or it's not handling messages that it's supposed to. In either case, you want to know about that. That's what this little unhandled handler will do for us. Okay, so this looks good for a little hello actor. The next thing we need to go ahead and do is actually start this actor. So let's jump over to program.cs and let me add a little bit of padding here because we want to make sure we start this actor before we call terminate on the actor system. And you know, this looks pretty good. I'm going to go ahead and rearrange this just a little bit. GitHub Copilot's doing a lot of good heavy lifting for us here, but let me rearrange that. First thing we're going to go ahead and do, I guess I like using var, but for the sake of doing a tutorial, probably better if I don't. This is going to be the formula we use to start a hello actor. And then we're going to pass in these props down here, create an instance of the hello actor, and get an IActorRef to it. And then finally, we're going to go ahead and send a message to this actor. Yep, that looks pretty good. I'll explain the dead letter piece in just a second. And then let's go ahead and do a little bit of request response. Request response with the hello actor. Well, almost GitHub Copilot almost got it right. We want to accept a string back, and this will, you know, rather than accepting a task, let's just go ahead and await this. We'll go ahead and do a string, and we'll await, and then we'll go ahead and call, oh, I don't know, console.writeLine. There we go. All right, so what's going on here? The way we start actors is we use this little configuration class called props. Props basically defines the type of actor we want to start, what constructor arguments we're going to pass into it. And it's also possible to pass in some other configuration elements as well, such as we're going to learn about like routers later, which allow us to create groups of actors of this type that we can like load balance messages to. But I can also do things like, if I really wanted to, I could customize the mailbox, or I could customize the dispatcher, or I could even customize the supervision strategy this actor uses to manage its own children. So props is more than just specifying the type of actor. It's really kind of meant to be a formula for how to start this actor. And we'll learn a little bit later once we get into things like actor supervision, how this props gets used to help recreate actors in the event that they crash while they're processing messages. So to actually create an actor, we need to take the props that we created earlier, and we need to pass that into the ActorOf method. And we're calling ActorSystem to ActorOf. This will create a brand new top-level actor, and we can optionally give this actor a name. In this case, we're just saying hello actor. If I got rid of this property, this code would still work just fine. We would just get a randomly assigned name that's guaranteed to be unique. And that's kind of another important thing I should mention. No two actors at the same position in the actor hierarchy can have the same name. That'll create a duplicate actor name exception, and the second actor with that duplicate name will basically be blocked from starting when that happens. You'll get an exception in response. So actor names must be unique, but only for each level of the actor hierarchy. So if I have, let's say, two different actors that are siblings, they can both have a child named Bob, and that'd be fine. But they can't have two children, but one of those actors can't have two different children, both named Bob. That would be illegal. So finally, we get down to actor messaging right here. The primary way we message actors is through the tell method. Now, the tell method, as you might see by my highlighting here, is a void method. It's asynchronous, though. It's async, but it returns a void. The reason why it's asynchronous is that the tell method only exits after we've guaranteed that the message has been queued up inside the actor's mailbox. It doesn't guarantee anything about the message being processed or make even any guarantees that the message will be processed. All we get back when we do a tell is just an acknowledgement that the message has been queued into a mailbox for future processing. So the amount of time between calling tell and the message actually being processed usually can be measured in nanoseconds. It's very fast typically. Kind of depends on how busy the .NET thread pool is. But generally speaking, it doesn't take a huge amount of time. Now, if you want something a little bit more robust than fire and forget messaging, this is where we can use the ask operation here. This does request response messaging. So if you were going to integrate this actor into something like an HTTP controller, for instance, this would probably be the method you'd want to use. You pass in an input, you specify what type of output you want. If you don't want to specify an output, you can get rid of that and it will just return an object back is what it will do. But we're going to specify our output type here. And if we get something returned that's not a string, this will throw an exception. It'll basically throw a type mismatch exception or something like that. And we're going to await on the task that gets returned by this ask operation here. And we're going to write that response out to the console. One other thing I can optionally do right here is specify a time span. So let's go ahead and do, I don't know, let's give it 3 seconds, I guess. I can also use cancellation tokens to time out an ask operation too, if I want to. So let's go ahead and run this and see what happens. Okay, so here we go. So let's see, I should probably, let me restructure this. I'm going to do tell and I'm going to do ask right here just to make it a little clearer where each message is coming from. Let's go ahead and run that again. Okay, there we go. So one thing you'll notice is that the way these messages get logged, tell always gets processed before ask. And if I ran this 2 billion times, it would show up that way each and every time. This is because we know that when the tell method exits, this message is guaranteed to have been queued inside that actor's mailbox. Well, ditto for the ask operation. This is actually doing a tell underneath the covers. All that the ask operation is doing in order to close the loop and work properly is this sender right here is actually going to point to a temporary actor the ask operation creates. And that temporary actor will use the response to complete the task that was returned here. So that's all that's really going on under the covers. But one thing we always guarantee about Akka.NET actors is they process messages in, first out order. And that's because the mailbox that actors use is a queue. It's a concurrent queue underneath the covers there. So that means that if we send messages in a order, 1, 2, 3, the actor will process those messages in that same prescribed order. That's very useful from a design standpoint because it helps simplify what we need to do on the sender side if we want actors to process messages in a particular order. Any sender can sequence messages to any receiver in a specific order, and it's guaranteed that the receiver will process them in that order. Now, if we take a look here, you will notice that we got a dead letter, that this string from the hello actor to dead letters was not delivered. This is because this operation right here does not actually have a sender. We are sending this actor a message from outside of the ActorSystem. Therefore, this sender property will basically point to the dead letters collection. Dead letters is where undeliverable messages go, meaning that there's no alive actor available at that actor reference location. So when that happens, we get a dead letter. Most of the time, a dead letter usually occurs when actors or an actor system is being shut down. And so therefore, it's kind of a nothing burger when that happens. However, dead letters are also something you might want to take a look at if you're monitoring an Akka.NET application because it might indicate a programming error. For instance, it might indicate that a bunch of your actors are talking to another actor that shut itself down at some point, and you never recovered from that, never reacted to that, and therefore you have a bunch of messages that are being sent to someone who's not listening. So there might be some good reasons for taking a look at that. Finally, if we scroll down here, let's see, we've got this and this. Where is my response from hello actor? Where does that get logged? Down here. Here we go. Response from hello actor. Whoa! That gets logged at the very top of our messages, even though it happens last. That's weird. What gives with that? Well, this is actually not that weird. This is a common feature of preemptive operating systems. Here's what's really going on here. When we called log.info, the way the Akka.NET logging system works, and we do this in order to make sure that logging can never block actors from running, this actually creates a little event that gets published to the built-in event bus inside the actor system. And in fact, I can pull that up right here. It's the event stream. This little event stream right here is basically a little topic broker that uses C# types as its sort of means of referring to different topics inside the system. Well, when we call log.info, this actually publishes a log event to that topic, which gets consumed by an actor and then written out to the console later. Whereas this console.write line right here executes inside the foreground thread of the console application that we're launching. So all these actors might be doing their background work, and they might have to do it first before we get this response back at the very end down here. But the actor that's doing all of the logging may not be scheduled until after this completes. So this is not meant to confuse you. This is meant to just kind of show you, look, every actor is guaranteed to basically process messages in their prescribed order of execution. But when you have multiple actors running, or you have, in this case, non-actor async workloads running, ActorDonet's not going to try to enforce universal ordering, and nor should it. That would produce extremely brittle, extremely slow applications if we did that. So that's why this particular line showed up first. It's just that this thread of execution was already running. It ran into one await statement, and as soon as that operation came back, it wrote out to the console. Whereas the actor that was scheduled to write out all these log messages may not have been given a chance to run until after this await operation had already completed. That's just the nature of non-deterministic operating system thread scheduling. So that's kind of it for our first little lesson here in Akka.NET Bootcamp Unit 0. Let's go ahead and flip over to the next unit where we're going to write for real our word counter.